Right. OBS studio is on. So now it's recording. Okay, so just some quick housekeeping. Basically, we will attempt to record all our lectures. Okay, attempt. That's also part of the reason why I have teaching assistants, because they will help me make sure all the technical things are done, so that I can just focus on teaching. And then at the same time, we will go through the course overview first, and then followed by the lecture. Okay. I think a lot of questions that some people are asking me about groups for this semester. So we will talk about that then. Okay. See, yes, your question.
Yeah, sorry, doctor. Your voice just turned to be electronic.
Okay. Is it better? Is it okay now?
Yeah. Thank you, doctor.
Yeah, I think my data just dropped a little bit for my recording. Okay, so we'll talk about groups a little bit later. Okay, at the end of the class, just in case everybody disappears. I'm also expecting more people to show up. I'm not sure why. Because on my participant list, I think I have about 132. So today I only have about 115, 114. Audio is still cutting in and out. Okay, one moment, yeah. Perhaps I'll turn off my video. Perhaps I'll turn off my video. That may help my audio a little bit. Is that better?
It's okay.
Yes, doctor, much better.
Okay, that will help better. Okay, so let me just put a pin. Okay, so in case my audio drops out again, please let me know. Okay, and then after that, hopefully we will have no other restrictions later. I am going to now move on to something else before we continue on with the class. Let's see. All right, so everybody should have access to Spectrum, right? We will use the same meeting link every week for the first 3 weeks. Okay. The first 3 weeks is basically the end of the Ramadan month, leading into the Eid festival, which is on week 3. So for the first 3 weeks, we will only be having our classes online. Okay, during the first 3 weeks. So during this time, okay, we will be using Google Meet. All right. In case anybody is having any issues with Google Meet, please let me know. Okay. And also we will be having our class from 6 to about 8-ish. Now, for those of you who are fasting, okay, feel free to take your breaks when necessary. Like I said, we will be recording the sessions. And also we will try our best to recap a little bit. We hope to take a break at about 7:15 or so, okay? And then after that, continue on after that. So let me just get started with some of these documents to kind of explain a little bit about what we're doing, okay? So the title of the course is Big Data and Science Communication. Always pay attention to your course learning outcomes. Course learning outcomes over here. Okay, because this will basically give you an idea of what we're trying to establish by the end of the semester. The first one is to explain various types of storage infrastructures, including understanding of technologies ranging from traditional to cloud-based storage. Second one is to explain recent technologies in manipulating, storing, and analyzing big data studies. And the last one is the master steps of the big data processing. as well as reporting and presenting results to audiences of all levels. That's essentially what we're planning to do. So this one never changes. Okay, performa as always stays the same. Okay, so course information. Now, today is 21st of March. Today is your first lecture. Okay, it's the introduction lecture. We will be covering all of these different lectures over time. Second lecture will be next week, and then there are very limited public holidays for Friday this semester. Okay, so we will generally be having our lectures as scheduled. Now, first question on everybody's mind is, when am I traveling? So my only really scheduled travel for this semester is during week 9 and week 10. Okay, so during these 2 weeks I will be away. All right, and I will be overseas. So we are planning to have a guest lecture on week 10, and then on week 9 we will have group activities. So there will not be, or you'll not be seeing me during this period of time. Okay. This course basically runs on a 60% 40% ratio. 60% of it is continuous assessment, which means that your midterm test is set at 20%. Okay, and then there will be 40% for your presentation. Okay, your final exam will be a 40% final exam at the end of the semester. Open book. Okay, so it will be a similar situation to last year. Okay, there will be 2 rounds of presentations. All right. What will happen is that we will cover the first 6 weeks of classes. Okay, and there will be a presentation for your first seminar. Okay, and then after that there will be a break in between, or during the second week of May, and then we will come back on week 8 for your midterm tests. Okay, and then after that, that's basically the halfway point of the semester. And then after that, we will actually have some time to actually work on your assignments. And then week 10 there will be a guest lecture. And then after that, after I get back, we will do another round of presentations on week 12. Okay, and then another round lecture week 13, and after that course summary on week 14. Is that clear, everyone? So from what I see so far, no public holidays as yet. Okay, but if anything happens in between, we will deal with it during the semester. Okay, assignment. Okay, so your assignment, basically is a total 40% assignment. Okay, your assignment basically looks into building no-code big data analytics for science communication. Now, in groups, your job will basically be to conceptualize a big data analytics web application for a science communication use case. Okay, which means to say that you have to decide on a solution using big data analytics to be used for a science communication purpose. Okay, you're going to be using no-code tools to actually design, analyze, and interpret data insights. So you need to basically pay a lot of attention to your tutorials, because they will give you the tools to help you to kind of put together your assignment. Okay, so your presentations, okay, would be to basically showcase an app design and user journey. Okay, and then after the first part of the first presentation will be to talk about what is the problem that you notice, and how will you use these analytics to actually provide insight into the problem. Okay, so keyword here is provide insight. Yeah, provide insight means to say that you are actually delivering some degree of understanding. Okay, I'm not asking you to cure cancer. I'm asking you to basically provide us some degree of understanding that typical analytics is not able to do. Okay. Now, an example of this is to analyze public engagement trends in science-related news, identify misinformation patterns in scientific topics, or understand how different audiences react to climate change reports. Okay. So there are different types of ways for you to actually determine these problems and these use cases. We will discuss this during the first half of the semester as we go along. Okay, so don't have to worry about it now. The outcome of this is to basically determine or to create a wireframe. A wireframe, okay, this is something we will discuss in more detail next week. A wireframe basically is your storyboard, okay, or your layout of your proposed app. All right. It should include your homepage, a data visualization dashboard, and also filters or other interactive elements that users can actually use. So there are free tools available for you to actually use to actually build this. Okay, and then you can map out your user journey based on how they would access the app, what actions they would take, what insights they gain, all these sort of things. Now, our design for this assignment actually follows the different steps required for product development, especially for app development. Okay, and some of these things are elements that we took out of some of the courses that I was attending through the Deep Tech Accelerator program. Okay, so some of these things, it's not so difficult. It actually can be quite doable for you if, let's say, you don't come from an IT or an AI background. Okay, second part. Okay, second part is to demonstrate how this data insight and visualization is going to happen. So first thing is that we will actually help you to actually determine what is a real world data set. Okay, using some of these tools. We will actually you will actually try to explore how you can actually create interactive visualizations or different types of analyses using these results, using these kind of tools, and basically develop some degree of value proposition or some degree of interpretation for your data. Okay, so some of this data, it is very much learnable. Okay, it's something that you can actually pick up and something that you can actually try to explain over the course of a presentation. Now, the first presentation will be assessed by myself alone. Okay. The second presentation, I've actually invited um, a participant to actually assist with the um, assessment. So, if you guys are you guys looking at my screen right now? So this person is basically okay. Well, anyway, but basically, I have been in touch with this lady from Guoke, okay, which is a company that's based in China. Essentially, I've actually tried to get her help to basically look through the presentations and and actually give us some sort of feedback on your presentations. So what will happen is that because of this new thing, the second part of your presentation, right, will actually be a video submission. Okay. So the first presentation will be a physical presentation. Okay. Where everybody in the group will have to help present. The second presentation will be a video presentation. Okay, which you need to submit by week number 12. Okay, or that particular week, which I will mention later. Okay. And then after that, we will get her feedback on the groups and also her top 5 favorite videos. Okay, so this is one way for us to kind of get some industry feedback and whether or not they find your solutions interesting or not. Now, there are additional marks available if, let's say, you are able to create a basic functional prototype of your app using the no-code tools. Okay, but I will basically explain this a little later on as we go along. All right, so this is essentially the assignment. Any questions? out there? Can you hear me?
No, doctor.
No questions, huh? How many students per group? Okay, that would be a first very good question. Okay. There's about 130 of you. So I'm trying to make sure that I don't have too many assignments to mark. My intention is for your group to be about 5 to 7 people. Okay, 5 to 7 people in one group. Now, how do you select your group members? Okay, I will explain that at the end of class. Okay. Now, let's carry on with our lecture. Okay, so first week of class, I will try to keep it relatively short. Okay, but I just wanted to give you guys an understanding of what the semester will hold, a little bit of overview about what we will cover, and also a little bit of orientation into what is it that we're going into. Okay, so let's start with a very philosophical question. What is big data? Okay, now we know that data, okay, as you guys would have remembered from your methodology class, it refers to different types of quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. Okay, so this is essentially what is data. All right, so data, okay, ultimately information, okay, that will be stored and transmitted and basically uh, shared among people for various different uses. However, there is also this thing that has come out relatively recently in the last 15-20 years or so about the concept of big data. Okay, now it's not just about volume, it's not just about size. Okay, we understand that as our lives become more digital, our data becomes richer and it will grow as exponentially over time, especially in a world where we're living with AI, which means that AI is actually able to synthesize data for us. Okay, so what it means is that in the past we have to rely on looking for primary data, which means to say that if I want information or if I want data from particular people, I basically need to speak to those people in order to get their insights. I need to find a way to collect data from them. However, nowadays, because everybody is constantly engaging with each other digitally, okay, data is actually generated all the time. Okay, whenever you fill up a form, whenever you type a text, whenever you post something online, that creates data. All right. With AI, what it means now is that we are actually able to train AI models in order to synthesize data on our behalf, because they will run simulations in order to create data for us. Okay. So for example, right, in policy making, okay, just to extend a little bit from what we did last semester. In policy making, what happens is that a lot of policy scholars these days, what they do, especially in future study, okay, or in scenario planning studies, they're not really able to predict what will happen. But in order to circumvent that, they train AI models, okay, they train AI models in order to predict what kind of scenarios would happen over time in case certain factors exist. Okay, so for example, risk of disasters or risk of climate change or risk of political unrest and things like that. So these type of data will feed into a system and basically give them a calculation based on what is the potential outcomes of these scenarios. Okay. Now, I'm not teaching you how to do that. Okay, it's actually very complicated economics, but even I also don't really understand exactly what they're doing. But the point is this. Okay, we are dealing with extremely large data sets. We're dealing with very large data sets, and a lot of these things can actually be computed these days. Okay, either using different types of processors, different types of storage solutions and things like that, in order for them to reveal patterns, trends, associations relating to how we do things and how we interact. So these type of big data, right, is available out there, and actually is a very good opportunity for people who actually understand this to try to find ways in order to make these data sets more useful for us and help us to create more value. Okay. Now, what it means for people like us, right, who are working in communications, who are working in social sciences, it means that we are able to gather more data more quickly with less hassle, as we in this new age. Okay. So let me just push it a little bit further. Okay. I seem to be going ahead of myself. So what I meant by that is that with the kind of data that's available to us, okay, we are able to find ways to answer deeper questions than we previously had thought of, and also we are able to get answers from models that doesn't require ethical clearance. Okay, so once upon a time, every time I want to ask somebody a question, I need to basically go through an ethics committee first before I can actually ask that question. Nowadays, what we're actually able to do is that we can train AI to answer our questions for us. Okay, so that means that we don't actually have to rely on humans, and we don't have to worry about whether they get offended or not by what we're saying. Big data also allows us to gather and compute huge data sets from different types of sources that have been generated on their own. So, for example, some databases like Reddit, or others that are available for a fee, you are actually able to actually dive into their data because there's actually open source. Okay, which means that you can actually create different type of reports based on those data if you know what you're doing. Okay, I don't want to ramble too much because I know that I'm starting to sound very geeky. Okay, let's just dive into the more functional or more basic ideas about what I'm talking about. Ultimately, data can actually be separated into two different things. Okay, the first one is attributes. Okay, attributes relate to, if you think about it as a spreadsheet, attributes relate to columns. Okay, which means to say characteristics, different types of dimensions, different types of features, different types of variables. Okay, so imagine a Google form, right? Every type of question you ask in your Google form will create a new column for you, okay, in your spreadsheet. Okay, every time somebody answers the Google form, it creates an object. Okay, so every time somebody answers the Google form, a new row will appear. So these new rows are basically your sample, your individuals, people who are giving you data based on the attributes that you have asked. Okay, so this can relate to different types of sets. Okay, so for example, if I'm building data based on news articles, okay, news articles, I could have one column that talks about the source of my news article, or rather the media source, like for example, what newspaper, what TV channel. Another column could be talking about who is the writer of this particular article. Another one could be the title of that particular article. And then another one could be perhaps the text of that particular article. Okay, and then the last one could be maybe the date that the article was published. Okay, so the way you gather data and the amount of detail, okay, in your data set, right, gives you more information that you can play with in order for you to determine what are the patterns and also what are the trends that you're able to kind of detect. So in a narrow sense, big data really only refers to how much sample you actually have. Okay, so some people would relate to big data according to how much space it takes up. Okay, which is a very narrow way to look at it. In a broad sense, we talk about big data, it represents both the sample size and also the degree of dimensionality. Okay, let me just shut my door. Now, big data, right, can be useful, it can also not be useful. Sometimes we have a lot of data, okay, and this data may give us a lot of information, but information does not necessarily mean that it gives us knowledge. Okay, so you have data from all kinds of different things. Nowadays, we have data from traffic lights. We have data from how many people crosses a border in a day. We have data from articles that are being published online. Even nowadays, if we're talking about sustainability, we have a lot of data from what we call geographical information services. And a lot of this data are available for free. Okay, there's a lot of open databases, open data versus, different type of things. They have this thing called data sanctuaries, different types of different places where data can be stored and can be accessed by different types of individuals. So like in China, I think there was this huge database for social science research, okay, where they will have open databases there. Unfortunately, because I don't read Chinese, I can't really remember where it comes from, but I remember seeing some of my students actually presenting this to me. Okay, so these are some of the things that we can consider as big data sets. Okay, the more data we have actually creates more demand for data scientists. Okay, but it's not just enough for them to know how to manipulate data. Actually, what's more important is not so much the data scientists, but really what kind of problems can we detect that data scientists can actually um, solve. So, for example, a lot of IT graduates, right? They have a lot of skills, but they don't know what are the problems that they're supposed to focus on, or what can they actually focus into. Okay, which means to say that sometimes it's not so much important for you to have more and more IT personnel. It's more important for you to have people who understand that big data can actually create a solution for these issues. Okay, and these problems come from all sorts of different types of all kinds of different sort of sectors. So, like for example, in manufacturing, nowadays we talk about automated manufacturing. Okay, because in the manufacturing industry, there's a lot of need to replace manual labor. Okay, the people who actually need these solutions are not data scientists. The people who need these solutions are actually more mechanical engineers. So mechanical engineers find computer-based solutions in order to make their processes more automated, and that will help them to actually regulate their machines better, reduce and help the business reduce their costs by meaning that they don't have to hire so many people. And also, it creates a new type of product, a new type of service, a new type of industry. Okay. In the same way, science communication, or rather communication and media industry people, okay, they actually have a lot of opportunity to use big data to add value to their sector, because in media and communications, the data is generated not just by the media practitioners, but also by the users and also the audience themselves. Okay, so we're talking about people who generate data because of their watching, for example, their watching habits, or their viewing habits. Sorry, that's the proper word. Viewing habits. So, like for example, there is a big data algorithm there, sitting in a lot of these streaming services, okay, that actually recommends shows to you based on your viewing history, okay. If you take for example like YouTube, okay, based on whatever videos that you have been watching, it will basically recommend new videos to you for you to see, okay. A lot of it is based on previous data that you have actually entered, and also based on a lot of things like your demographics, what you expect you to be interested in, and things like that lah. Okay, so yeah, nonetheless, okay, there is still a gap between the information that's available and the knowledge that actually provides to us. So it's up to us to close that gap over time. Now, what is big data? Okay, once upon a time, okay, big data was not very big. Okay, once upon a time, big data was really about collecting information that we felt was important. So, for example, in this particular use case, right, we're talking about retail. Okay, retail relates to whenever you go to a shop. Okay, like for example, if I can just dive into a little story here, perhaps before a lot of you were born, okay, I got my first computer in 1995. Okay, my first computer came to me in 1995. I was 11 years old. Okay, so I learned how to use a computer. I remember a time when I didn't know how to use a computer. Okay, let's just put it that way. During this period of time, okay, in the 90s, right, we talk a lot about digitization, okay, which means to say that we talk a lot about how can we put our physical records. In the past, it was all paper filing. Okay, how can we put our physical records into a digital format? Okay, so in 95, in 2000, they started using these enterprise resource sort of programs, okay, in order for them to automate or to kind of make sure that a lot of this data is captured in spreadsheets, okay. So the first spreadsheets were developed without the use of Windows, okay. It was more important for you to have a spreadsheet than it was for you to have Windows. All right, so if you can imagine, once upon a time, everybody need to know how to use MS-DOS, which means to say that everybody knew how to some degree know how to code in order for a computer to work. Okay, so during that period, you had people, or rather clerks, who would spend all of their time basically turning paper documents into digital documents. Okay, after that, when data solutions became more available and the amount of space actually increased. Okay, once upon a time we only had megabytes. Okay, for example, I still remember my first computer was a Pentium 2. Okay, Pentium 2 processor, which today which is actually no longer, which is now I'm using an i7, okay, which is way faster than what I used to have. I had less than 1 gig of RAM. Okay, I only had about 256 megabytes of RAM. Okay, so you can imagine, right, the degree of functionality that was available to me was actually very limited. Okay, however, then the amount of volume of data, or rather the amount of memory and also the type of data space was actually grew. Okay, then after that you went to CRM, okay, which meant to say that you talk about customer relations management. Okay, now during this period, okay, people started to record down their client relations on a computer, which means to say, for example, every time you make a visit to your client, okay, you need to type up a report in your computer. Okay, so that was around the time when a lot of people started to have laptops. All right, that was a lot of time when a lot of people started to have laptops, and every time they finish a visit or whatever, they need to update their CRM. Okay, it was also around this time that perhaps internet became a little bit more available. But having said that, available does not mean that you have internet. You don't actually have data on the go. Okay, you don't actually have smartphone just yet. Okay, you're still relying on internet cafes. You're still relying on cable data. Okay, you're still relying on a lot of like low tech stuff. Okay, that was CRM. Okay, and then after that, we got into web-based data. So then once you get up to terabytes of space available, once you have strong processors, once you have network connectivity, and you start to have these cloud services, okay, it means to say that you are much more that you have a lot more options available to you. And it was also during this time that people started playing around with different types of algorithms for search, for to look into pricing, okay, to calculate things like that, look into networks, and different types of applications started to be developed during this period. And then we move into what we see today. We have a lot of big data that comes from different types of places, and we have a lot of algorithms that are able to help us to determine different things. So for example, the straightforward one will be how many clicks you get, which is something that we tend to see all the time. Okay, that was something very early. We have web services available to us on mobile. Okay, on top of that, we have a lot of IoTs, Internet of Things devices. So things like sensors, RFID, different types of devices. That actually helps to capture data as well. And based on the data that we have, we are actually able to detect certain patterns. So for example, how do you tell when somebody is happy with you or somebody is angry with you? Okay, so you have different types of sentiments that are being processed based on what we call natural language processing. Okay, so different types of data, right, starts to exist. And during this time, what that means is that the type of variety of data that is available to us, as well as the complexity of the data, actually increases over time. So with more space available to us, with more infrastructure available to us, then you're getting a more different types of data and more complex types of data that are coming into the picture. With the current move into AI and also with the current move into different types of computing, next generation computing, what this creates is a situation whereby we are not really too sure exactly what type of data will be available to us in the future and whether or not we are able to crunch it and make sense of it. Okay, right now, in a sense, we have not fully understood the frontiers of what is available to us. Okay, so let me just double check my time. So what does big data actually refer to? Okay, it refers to data that is large in size, that's important, that perhaps cannot be computed or processed by a single laptop or a single computer. And it is also data that tells us a lot of different things. Okay, so big data actually relates to a lot of different aspects of our life. It is about the people that we interact with. It is about how they behave. It is about what they actually want and actually what they desire. It's about what we actually have, and it's also useful in many different types of fields. In a sense, everything that you do with a digital device creates data. Okay, and this data is when it's created communally by various different types of people. It tells you a lot about what you guys are thinking and about how you guys are behaving, which is why privacy and in a sense security is a big question mark when it comes to data. Okay, and it's something that a lot of people are very concerned about. Okay, it is also why a lot of, as far as policy is concerned, a lot of countries take a lot of steps in order to safeguard their data. Okay, they prefer it if, let's say, the data is for their country is essentially being stored by their own companies or by companies that are aligned with their particular national interests. So obviously, like in China, they have their own IT companies, they have their own data companies. You have your Huawei, you have your Tencent, you have Alibaba. These are companies that work, essentially are internet companies that basically create a lot of value in this area. In Korea, for example, you have this company called Kakao, okay? And then in different parts of the world, in Japan, they also have their own thing going on. But the point is that most countries would be will be not so inclined to actually have their data sitting on a server which is in another country that they are perhaps not really good friends with. Okay, which raises the question why Malaysia is so happy to use Google and YouTube and Alphabet and Meta and all of these different types of sources. It's a question that we need to answer for ourselves. Okay, but the truth of the matter is that we don't really have a big enough population to actually justify having our own infrastructure for everything. Okay, we're going to cover a little bit about the characteristics of big data. Okay, I'm just going to push a little bit more. Hopefully, I can. We're going to go on the way until 7. Is Umaira in the room? Is Umaira here? Umaira, are you there? Umaira is.
Sorry, Doctor. Do you call me?
What time is breakfast?
Oh, okay. Oh, it's on 7
7 p.m.
7:26.
7:26. Full day.
7:26.
Okay.
Yeah, around that time, 7:26, 7:25. Yeah.
All right. Cool. Thanks. Okay. I tell you what. Let's take a break now. Okay. Let's just take a quick 8-minute break. We'll come back at 7 o'clock and continue on with the second part of this lecture. Because I think that if you want to wait until after, it's a little bit too late. Okay. So let's take a break now. Okay. So we're going to cover 5 major characteristics of big data, and this is something that we will come back over and over again to talk about infrastructure for big data, which we feel is probably going to be a big feature or a big theme that we will cover in the next 3 to 4 weeks. Okay. Now, the first characteristics is to talk about volume. All right. In this particular story, volume is becoming less of a problem and more of a problem all at the same time. All right. Why do I say that? Because we have more and more data centers and more servers available to us, which means to say that our capacity globally, okay, at the moment is still relatively okay. However, there are considerations that has to be made, right, with regards to volume, because the more data centers we run, the more heat we generate, first of all, and also the more energy we consume. Okay, because these data centers have to run all the time and they get hot. Okay, so which means to say that you have to find ways to basically keep the temperature down. With that in mind, you're spending even more money on energy lah. Okay, first of all to run the systems, and also A and B to keep the temperature down. So there has to be new ways to actually kind of create solutions for this. Okay, on the one hand, we can create more and more data farms if we want to. On the other hand, there also needs to be new technology in how we store data as well. Okay, so once upon a time we stored data using tape. Okay, tape gave way to basically laser disc. Okay, so there's all this kind of materials, this kind of advanced materials, and these are actually getting more and more rarer as we go along. Okay, now that creates a new challenge for the world we have today. Okay, nowadays if you have heard about this before, there is now a race for what we call critical minerals. Okay, critical minerals are basically the raw materials that are used to actually power or to actually run the semiconductor industry. So I saw a hand raise. Yes, Joey.
Hi, doctor. Sorry, I think you haven't shared your screen, so we can't see
No wonder.
your slide.
Sorry.
Yeah, thank you.
Thanks for informing. I miss the days when I could just do this physically and don't worry about all this. Okay, here we go. So, with relation to volume, right? So when we talk about critical minerals is now a big issue that we're talking about, because a lot of the minerals required to actually create batteries, to actually create microchips, to create all of these memory cards, are essentially coming from the global south or the developing world, or mainly from countries like China and countries like Malaysia and different types of countries that are willing to go and dig up all of this dirt. Okay. And with that in mind, this means that the shift in power actually changes, and also the price of goods actually increases. Okay, if you guys might have remembered in during COVID, right? There was a period where phones, they did not become more expensive, but they become a lot harder to get. Okay, because the production of these phones and the production of electronics actually dipped because the raw materials were not available. Okay, so scientists are still finding new ways in order for us to store more data on less material, or finding new ways to actually store data in general. Okay, so with that in mind, right, that's how we are sort of trying to go across this particular first characteristic. Okay, I will discuss this more in more detail next week when we talk about scalability. Okay, but I'm just getting a little bit ahead of myself lah. But the first thing is that we need to talk about it is basically volume lah. Okay, how much data we actually have available to us. The second thing is about velocity. So how quickly are we actually producing data? So like I was saying earlier, if you can imagine, every time you type a text, every time you post something on a platform, every time you cross a toll gate, okay, you're generating data. All right, so a lot of systems are actually generating a lot of amount of data at a very fast rate. Okay, so with that, the velocity of data that's being provided, right, okay, actually gives you a sense of what big data actually looks like, right? So this is the type of velocity that requires processing power in order to overcome. Okay. Third thing is variety. Okay. So big data sets, they can be large in terms of volume, but not necessarily very different from one another. Okay. So for example, there was this company that I visited called UEM Agenta, right? And because they are a facilities company, okay, they basically provide facilities for hospitals. They take care of their cleanliness, they take care of their power, they take care of the utilities and things like that. They manage the building basically. So for them to do that, they need to have a lot of different devices that capture a lot of different types of data. Okay, and means that they have different types of data in very different formats. And these various different formats need to basically be able to sync with one another and make sense to different people. Okay, so I don't want to go into too much detail, otherwise everybody will get very confused very fast. Okay, the fourth thing is a little bit more difficult. It's talking about this concept called veracity. So veracity actually talks about whether or not the data that you're capturing is accurate or correct. Okay, this is the most important thing, because sometimes when you can be collecting a lot of data, but your data is very dirty. Okay, your data can be very dirty. All right, which means to say that your data is not very accurate. Okay, when your data is not very accurate, right, it creates a lot of false positives. It creates a lot of noise in your data. It doesn't give you very actionable intelligence. Okay, so a good big data platform or big data solution, right, has to have this in mind from the very get-go, is that when you are building your data set, it has to be verifiable and it has to be correct. Okay, this relates to something that we discussed last semester when we talk about data, when we talk about validity or accuracy of your data. Okay, so when you are designing algorithms, for example, or when you are putting together new data platforms, you have to make sure that your data meets the veracity test lah. Okay, the last V, is probably the hardest to prove. All right, it's the hardest to prove. Okay, because on the one hand, volume is a question of capacity. Okay, it's about how much space you're taking up. Velocity is about how quickly you produce your data. Okay, how much data is moving and how quickly are they moving. Okay, these two things I think everybody can understand, right? So basically, for example, if you buy a big enough hard drive, you have good enough volume. If you have a strong enough processor, you are able to produce data at top speeds. Okay, the next three is a little bit harder to talk about. The variety. When you have different types of data, different types of devices, different types of information, how do you actually structure them together in order for it to make sense? Veracity. When you have doubt in your data, when your data is not complete, when it's ambiguous, when there is issues of deception, when people are not sure, okay, how do you take the doubt out of your data? The last thing is value, okay, and we're going to spend a whole lecture talking about value. All right, how can you create data that is valuable to other people, that people are willing to pay money for? Okay, how do you create data that people are willing to actually invest in? Okay, that's the hardest aspect. Okay, so here, these 5 characteristics basically gives you a sense of what kind of data is available and how are we able to actually harness all of these things. Okay, this was the initial break time that I was supposed to have, but it's okay. Okay, so what kind of fields actually require big data? Now, actually a lot of fields, right, can actually create big data. Okay, we see, for example, okay, I'm going to start from the bottom here. For example, a lot of businesses these days, they actually require a lot of their business to be digitized. So that means that even at the point of sale, okay, for example, if you go into a convenience store, if you go to a restaurant, at the point where they are taking your money, okay, at point of sale, at the register or at the cashier, they are actually using a digital equipment in order for it to basically be uploaded into a desktop or into a laptop or directly onto a web-based server for it to be computed. The point of this is because accounting wise, this actually allows them to basically have automated records, okay, for the purposes of taxes and also for auditing. Okay, so the first thing is for accountants and businesses. Okay, that is what they do. A lot of businesses these days are also what we call electronic businesses. So meaning to say that they may be selling things on Shopee, they may be selling things on Lazada, okay, they may be selling things on Taobao. And a lot of these businesses actually rely on big data analytics for them to understand their customer, for them to understand their reach, for them to actually sell ads, okay, to find ways for them to actually market their products, and so on and so forth. Okay, so a lot of these fields actually utilizes big data on a daily basis. Aside from that, okay, you also have fields that are a little less likely. Okay, things like literature, things like society, They also use big data in order to understand what their market is actually looking for. Okay, things like law. Okay, perhaps they also may be actually looking at big data, or rather, these kind of big data devices in order for them to capture law infringement or to capture potential problems or potential crimes that have been committed. Aside from that, you also have, especially in health and pharmaceuticals, there are a lot of apps these days that actually help people to track their health. Okay, and these actually produce big data analytics based on your behavior, based on your habits, based on your intakes of different types of medicines and things like that. Okay, so different types of fields would require big data for different types of reasons. Okay, and for example, if you think of like a large engineering firm or like a large, like for example, MRT Corp, when they're building the MRT, when they're trying to maintain the MRT, okay, that's running through our city. Okay, there's a lot of data that runs through their systems. Okay, like for example, how often their train runs, how many problems have there been detected in their trains. Okay, how many unplanned stoppages do they have, and things like that. Okay, so when you walk into a command center of a particular train company, right? Like for example, I've been to ERL before, the airport rail, basically. You can see all of this data appear on the screen. It looks sort of like a space station, a space shuttle launch type of mission control. But basically, these are feeding information to the staff in order for them to make decisions to protect the safety of the passengers and also to ensure that their company is handling the risk of what's happening as it happens. Okay. So, like for example, UM Ingenta that I went to, right? Because they take care of buildings such as KLCC, they take care of buildings like various different hospitals and things. They even have data about how often the lift moves. Okay, they have data about how often the lift moves, how much water is being utilized, how much energy is being utilized, and things like that. And that helps them to optimize the operations or the processes inside the building, and help them to actually help them to inform their clients, and also help their clients to actually produce reports that are required for their own reporting lah. Okay. So here are just some examples. All right. So the most basic one that we can always think about is retail. Okay. So retailers always try to find ways to give themselves a competitive edge, and they find ways to actually get a leg up over their competitors. For them to actually do so, okay, they need to be aware of what their customers actually want and what they actually need, and they need to find ways to actually fulfill those needs. Fulfill those needs in a timely manner. Okay, so a lot of these large retailers, they spend a lot of effort in analyzing the way their customers behave and the way their customers think. Okay, so they try to find ways in order for them to actually make smart decisions about their operations. So they gather data from social media, they gather data from their loyalty programs. So now you notice a lot of grocers, for example, they have a lot of loyalty programs. They come up with their own app, okay, and they get people to scan their membership every time they go and buy something. The purpose is actually they want to be able to track your receipt to your person. Okay, the reason why is because they want to track your receipt and your purchasing behavior to your actual ID. Okay, which means that they can push you advertising related to products that you're willing to buy. Okay, and that also helps them with planning the inventory for that particular shop. So for example, like the one near my house is Village Grocer. Okay, yeah, some of you guys might know Village Grocer. And basically there's a loyalty program with Village Grocer called Bytes. Okay, so every time you walk up to the counter with your groceries, right, they'll ask you for your loyalty barcode. So before you start scanning your stuff, they'll scan your barcode first. And all of this stuff actually goes into points that your wife or your whoever cares about these kind of things actually go into their account. So what it means is that using these points, you can actually redeem certain things, or perhaps you can turn it into something else. But what it gives your retailer is basically data about what you're actually buying. And when they have enough data about what you're actually buying, that can actually tells them what to stock in their shop and what they should actually pay attention to not running out. Okay, so these kind of thing gives a lot of information that actually helps their not just their logistics, but also gives them an idea of what kind of consumers are living in that particular area. What kind of price point are they actually interested to actually work with? What is their monthly budget looks like? Okay, this actually helps them plan a lot of things, and that actually helps them to actually decide what kind of product should go into that shop. Okay, so aside from that, they're also covering social media as well. Okay, they might look into what are people saying about their shops, what are people complaining about, okay, and also what people are buying and what people are showing off. Okay, so having all of this information available to them, okay, gives them what we call sound intelligence lah. Okay, intelligence comes from if you think about in a military sense, intelligence talks about information that is meaningful to you, that is actually able to help you to actually get over something else lah. Okay, so why is big data important? Please don't pay attention to the lorem ipsum dollar stuff. It helps you find the right customer. It helps you to develop the product, develop your brand, and do social media optimization. Somebody raise your hand. Xiao Yu, you raise your hand. I think it's by accident. Okay. So with big data, okay, you can actually make better plans. You can make a promotion that is suitable to your product. You can also leave the users that will not be attracted to your product. Okay. So these are different things that you can actually make decisions using big data. Okay, next case study. Okay, so media and entertainment. So viewers these days need content according to their choices only. All right, one thing you notice is that content is something that has become a lot more personalized. Okay, gone are the days when people spend time watching these, in a sense, terrestrial TV channels where you don't really have a lot of control over what is being shown. Okay, a lot of that went away, especially when it came to when cable came to town. So basically, once we started having specialized channels for different types of entertainment, okay, then it started to segmentize, and nowadays it becomes a question of what media on demand. So basically, people only watch what they actually want to watch. All right. Now, in the past, companies would broadcast advertising randomly without any kind of analysis. So based on what the client actually pays for, okay, they will broadcast it during a particular spot, okay, based on demand. So once upon a time, cigarette companies would spend a lot of money on advertising. You will always get cigarette ads on television. And then in Malaysia, that became illegal. Okay. Then after that, you notice that, and I'm talking about the 80s here, 1980s. And then after that, you started having a lot of ads from different types of companies. And then after a while, right, we all started moving online. Okay. So after we started moving online, marketers had to find a way to actually get people to look at their products. Okay. So they started online advertising. Okay, so once upon a time, we have a lot of these things called web banners. Okay, we have a lot of web banners put onto different types of websites, And these web banners would basically show off different types of products, try to get people's attention, try to get clicks. And then nowadays, it's sort of gone away from the average website and it becomes more in streaming services, okay, where you will start seeing, especially if you don't subscribe, okay, then you'll start seeing ads pop up everywhere, okay. After that, they found ways, or rather, they start paying the right people. So, for example, if you pay Google Analytics, or if you're paying YouTube, or if you're paying Meta, they will help you to target the right segments for your products. So with big data analytics, okay, companies now are able to actually target their ads to attract the right customers and also broadcast it accordingly based on their clients' budgets to get maximum attention. So I don't know how many of you guys have experienced basically buying ads on social media, but it has become very, very targeted and it has become very, very scary. Okay, so it is very possible to get your right segments and get to the people that you really want as your customers. And the way that actually happens is because of big data and also because of analytics. So in media, platforms like Netflix, Spotify, YouTube, they use a lot of big data to analyze user behavior to suggest tailored content. Okay, so a lot of this is based on AI algorithms. Okay, they enhance engagement by predicting preference. A lot of these insights also help studios and creators identify trending topics and audience demands. So what this means is that even some content creators, they would actually spend effort to look into what are issues or what are situations that are on the verge of trending. Okay, on the verge of trending because they need to be there first. So they would find ways, or they will find scripts, and they will find different ways to actually get out their content quickly. And a lot of these are actually based off of the big data algorithms that are in play right now. Okay. A lot of these AI algorithms basically also helps us to determine what are the right scripts, right type of music, right type of video editing, in order to sort of optimize production of these media content. Okay. So media content creators, they are not necessarily the most creative people. Okay, let me put it that way. So for those of you who are trying to become media influencers, please be aware that a lot of these media influencers are having known, not say known that directly, but basically being, aware of some of these media influencers in and around my social circle. They actually have a pretty large team behind them. Okay, they have their producers, they have their videographers, they have their content creators and things like that. They are able to basically understand what is happening and what is trending and what is worth doing. Okay, so they find ways to basically make sure that the messaging is always on brand. They find ways to get brands to actually sponsor them. Okay, they find different things that actually helps them to kind of keep the machine moving. Okay, so being an influencer is not just about being very creative with what you do. It's also about having the right team around you. Okay. And aside from that, big data is also used by different type of marketers in order to produce precise and targeting marketing strategies. Okay, so predictive analytics basically helps media companies optimize ad placements for maximum revenue. There's an E missing in my slide. Okay. Aside from that, okay, regulators also use AI to basically detect content piracy and other types of fraudulent activity in streaming services. So, for example, if you use too much of a particular song in your particular video and you don't have the copyright license for it, then you will be flagged, okay? Or there will be different ways that intellectual property is actually protected in on a web-based server or on a streaming platform, okay? So big data can actually quite useful in the media sector, okay? And this is something that if you're well versed with it, it's something that actually helps you to kind of navigate the new kind of normal when it comes to the science communication career. Okay, right now it's 7:33. I'm nearing the end, and then basically we will talk a little bit about group formation for your course, and then we'll call it a night. Okay. So considerations for big data. With big data, the first thing that always comes to mind is about privacy. Okay. Now, whether we understand it or not, or whether we pay attention or not, a lot of us actually do this these days without even thinking. We are happy to give away our data as long as we get the services that we are asking for. Okay, so things like I sign up for Spotify, therefore my privacy is gone. Okay, I sign up for Google, and basically my privacy belongs to Google now. I sign up for Facebook, and Facebook owns all my data. Okay, so data security is a major thing, which is also why, for example, now that I'm on WeChat, technically speaking, Tencent has a lot of my information. Okay, so things like this is of particular concern, especially to a lot of different countries, and they feel that it's important for them to safeguard privacy of their not just their citizens but also their leaders. Okay. Another ethical consideration is that algorithms are not all made equal and they're not always fair. Algorithms are usually tracking behavior, and sometimes they may not necessarily ensure fair representation. So typically algorithms will always favor the majority, okay, because they're very database. Database solutions will always skew towards the majority that's actually entering into your system, which means that minorities would typically be left behind. Okay, this is one of the dangers, especially when you utilize big data for policy making, because when you utilize big data, especially things like surveys, um, things like sentiment analysis, things like that, there's always the fear or there's always the danger that you will leave out minorities or you'll leave out different types of data sets that perhaps actually gives you a lot of value, but because there's not that many of them, therefore they get lost in the noise. Okay, so it has to be considerations for this, and there has to be ways for us to be able to capture such case studies, okay, so that we ensure that it is being used fairly and being used responsibly. Nowadays we hear a lot about misuse of data. Okay, there is a huge outcry over deepfake data, especially now that AI is able to generate images and videos. Okay, so deepfake content is something which is people are still finding ways to actually kind of mitigate this or grapple with this. Okay. Also the issue of misinformation. So some people find whatever type of satisfaction on giving out misinformation. Okay, this could be done maliciously, or it could be done for greedy purposes and things like that. Okay, so misuse of data is a big issue when it comes to big data. Lastly is accessibility. So big data actually is very much favoring people with access. So meaning to say, for example, if I live in Kuala Lumpur and I have 5G network, okay, and I have access to all kinds of different things, then generally I should be okay. But if I'm living in a different part of the country which does not have all this access, okay, where my internet might still be intermittent, or I don't have as much money as other people, therefore I cannot subscribe to as much different things as other people, or I don't have access to broadband, therefore I cannot subscribe. It creates a disparity. It creates a gap between what people who have, and people who don't have. Okay, this happens everywhere. Okay, regardless of country, regardless of regardless of situation. So for example, if I'm living in Australia, if I'm living in the city, I would generally have access to a lot of different things. But if I'm, let's say I'm living in a rural situation, I may not necessarily have access. Okay, so in large countries, you see this happen very much. Okay, Malaysia is not a big country, but Malaysia also suffers from this because of our geography. So all this to say, we need to think about what is the future of science communication based on the impact of big data. We need to be very cognizant, we need to be very aware that the way science communication is being discussed today, the way science communication is being presented to you today by your lecturers, not to say that they're wrong, but the way science communication is being practiced today is not going to be the same type of sector in perhaps even 5 years' time or 10 years' time. Okay? Ultimately, what is science communication, right? Science communication is about bringing science as to the public, or bringing able to engage people using science, or making science accessible or meaningful to the public. Okay, one of the bottlenecks for science communication has always been the fact that we don't have a lot of science communicators. But the problem with that problem can actually be mitigated in the same way that a lot of media and journalism is currently being mitigated these days, is that we're reading a lot of articles that are not produced by humans. Okay, for example, if I follow basketball, right, and the truth of the matter is these big, large sports media stations, they are not hiring, or they are laying off a lot of their journalism staff, because a lot of the journalism work is being taken over by AI. Which means to say that, one moment, yeah. A lot of the stories that we are reading today is essentially being run by something like ChatGPT. Okay? So journalism is actually turning into something which is very fast, but it's very much powered by AI. Okay? There will be less and less opportunities for new journalists to enter into the market. There will be less and less jobs available for journalists. But what it means is that if you have a good handle on AI, perhaps you can actually create your own content, your own content producing company, or one content production company, which actually creates content for people to actually look into. Another thing that science communication actually does is very much in crisis communication. Okay, so in situations whereby people are misreading, or people are panicking over certain situations simply because they don't really understand it, okay, because of a science and technology sort of gap. This is a situation where science communication actually has a big role to play. Okay. Now, we're getting more and more of these data dashboards. Okay. And these data dashboards are very crucial when it comes to crisis communication. But there has to be a mediator or a medium that translates these data dashboards into something that people are able to digest and able to act upon during times of crisis. So this is a situation where science communicators can also play a role. Okay. Aside from that, science communicators are also very much involved in engaging with the public and producing immersive science experiences through things like museums, through things like science shows, and all of those various things. But these days, what we notice is that because of the lack of materials, and because sometimes it's very hard to bring these shows to underdeveloped countries, that perhaps AR or VR type of solutions are perhaps more economical to actually make that happen. So one thing we can actually notice here is that science communication is going to turn into very, very much a big data driven sector. Okay, which means to say that the future science communication graduate has to be able to harness big data, And I strongly believe that and I strongly believe that big data is not meant for just IT graduates. Okay, it's meant for more than just IT graduates. So yeah, this is just an introduction to what we're going to cover this semester. So I hope everybody finds this useful. I'm going to open up for questions right now. Any questions, anybody? How are we going to form our groups? Somebody has to say. Well, you can form groups of 5 to 7 people, and I will give you the liberty to pick your own group members. Is that okay? So I will release a form, okay? I will release a form over the weekend perhaps, or by next week, where you need to list down your group members and also give me a group name and also your group leader lah. Okay, that will be a requirement for next week. I will send it by WhatsApp. All right, so you can pick your own group members. 5 to 7 people means that I should not necessarily have anybody who is left behind. Okay. If you can't find a group or nobody is willing to take you in, okay, you need to let me know. Okay. Now, for housekeeping purposes, if you are not contributing to your group, or if you realize that one of your group members is not contributing to the project, okay, there will be a form that will be set up later in the semester for these kind of, in a sense, complaints. Okay, this form will need to be signed by all the other members to all agree that this person is not contributing to the group. Okay, if all the other members agree that this person does not contribute to this particular group, the assessment for the group will turn into an individual assessment, which means to say that everybody needs to note down which part they actually did in the final in the final presentation, okay, in a separate document. All right, and this needs to be signed off by all of the group members. Okay, that way I can actually determine who did what, and I will assign grades for them separately. Okay, I hope to not have too many of that particular case. All right, only if, let's say, everybody agrees that one person is not contributing, okay, then only we will switch to this individual format. And I can tell you now, if you switch to the individual format, it may not necessarily be to your favor. All right. If only one person feels that it is not if only one person feels aggrieved or feel that they were doing too much work, I will tell you right now, you need to pick your group members wisely lah. Okay, because you already have one semester under you already, you should know your classmates well. So basically, you should be able to make a very judicious decision about who you want in your group. Okay, so pick your own group members. You have 5 to 7 members in one group. Pick a group leader. The form will come out next week, and then if you have any issues, you can let me know so that we can sort it out by next week. Is that clear?
Yes, doctor.
Great. If there are no further questions, you guys can find me on WhatsApp. If you guys would like to discuss other things, you guys can let me know as well. For those of you who have approached me, we will discuss on Monday. Okay. And then otherwise I'll see you guys next week. On Friday night. Okay, same time, same place. Take care, everyone.
Thank you, doctor.
Goodbye, doctor. Goodbye.